Good afternoon, everyone. So really happy to see a full room to talk about iterators and generators. So before we go into the real subject, let's talk about who I am quickly, just so you know who I am. So I am Alexandre Daubois. I'm a Symfony lead developer at Dev Digital, which is a company based in France. I'm also one of the main contributors to Symfony, also the code and docs. Conference speaker, blog post, and book author. And this is the 7th time I'm in the Netherlands, because this is the most beautiful country in the world. So happy to be here to finally give a talk in my favorite place in the world. So as I said, I'm working at Dev Digital. Dev Digital is a company that is creating an application to create your house in 3 dimensions directly in your browser. And then you can do some photorealistic renders like this, or like this, or like this. And yeah, everything is on the browser, so you just jump into the app, and then you have all the tables, chairs, all the textures that you can see, and then you can pay to have photorealistic renders of what your house would look like. It represents 10 million projects created today. So it's pretty huge, huge in France, in Portugal. Our direct concurrent is IKEA Planner, which you may know. So yeah. So as I said, you can do things like this, and everything is part of one big JSON collection. Everything that you saw on screen, so the paintings, the pillows, and things like that, everything is part of a big JSON collection somewhere. We call it the model catalog. Yeah, I'm speaking about some collection, so let's see exactly what is a collection. So here is a very simple collection, the most basic one, let's say. A collection is basically a container of n elements which could be stored anywhere, so in memory or in a disk file or remotely, for example, an image or a file on a FTP server, etc. So this is the definition of a collection. This is just a container of n elements. A collection has 2 main things that you should know. So there is a stored collection order and maybe also the desired traversal order, which can be different. So here in this simple collection, this is the same order, but you may have some collections that are maybe shaped like a tree, like this. So the stored collection order is like a tree, but you want to traverse the collection from one edge to another. And even further, you may want this, because why not? Well, that's your choice. What if you can do all of this with just a for each? So let me show you what I mean by this. So let's say you have a new class that represents your collection. I'm going to turn off this one. He's going to spoil my talk, so yeah. So my new collection, and let's say we have a constructor which takes as parameter an array of your items, like this. Lots of typo. Okay. Yeah, all right. Let's make this public, for example. What is it? Constructor. What's the? Oh yeah, of course. Sorry, that's the first time I'm live coding for a talk, so yeah. Sorry for that. Okay, so maybe you want your items, and maybe you also want like collection direction, for example, like this. So we are going to declare our collection direction like this. So let's take an enum, and we have maybe forward, and then backward, like this. Okay. And then let's make this private. So you may want to have also set direction. Well, all that, all of that stuff that you are used to. And what I was saying before is, what if you can traverse this collection with just a for each? So I mean, doing things like this. For now, if you want to traverse this collection with an array of items like this, you have to do this like items. Oh, I didn't get items like that. Okay, you have to do this like this, and then as item, and then you can just display the item like this, and it should work as expected. Yeah, great. So that's pretty cool. Oh yeah, thanks. This is some pretty advanced PHP, so yeah, thank you. But what if we can do this like this, because this is a collection, so we would like to avoid having the get items, for example. Of course, this doesn't work. It is not wrong, because all objects in PHP are traversable. But it doesn't do what we want, because this is a collection, so we want to display our collection items. Okay, so this is what I mean by doing this by for each. We are going to see the iterator design pattern when a simple array access is not enough. So when you have this simple collection that is just a line, let's say this, you can easily use the array access like this, 0, 1, 2. It's logical, and you know which element you are fetching. But if you have this collection, then 0, 1, 2 is not that natural, and array access is not enough. So iterators are defining how a collection should be browsed, and this is the whole role, the whole point of iterators. You are going to define the way you want the collection to be traversed. So here is an iterator. You only need 3 things to go through a collection. You need to know the current element and the next one. And you can rewind to get back to the beginning of the collection, but actually you just need the current element and the next one, and just like this you can go through the entire collection. And then if you have this interface, the iterator interface, you can understand that you can create any type of traversal just by creating some implementation of the iterator interface. So flat iterator, random iterator, backward iterator, and so on. And it's super easy to create new ways to traverse your collection. The main advantage of this is that the inner structure is hidden of the collection. So you don't expose this to anyone. The access logic is decoupled from the storage. So actually the collection only stores actual data and does not contain any logic to traverse it. You can create a new traversal behavior at light speed, so as I told you, and it's easy to test because you have a test for your collection, if it really stores data, etc. But you also then have other tests to test the behavior of the traversal of your collection. So you are really splitting responsibilities here. Fortunately enough, PHP got your back. You don't have to create iterators yourself. There is an interface that's called iterator in PHP, which contains current, key, next, rewind, and valid. Valid is a function to know if there is any other elements after the current one. Note that the iterator is extending the special interface traversable. So traversable is some kind of internal interface of PHP. You cannot implement traversal yourself. You must implement this through iterator or another interface that's called iterator aggregate. But every object that is implementing traversable can be used in a for each loop. And this is the whole point, because when you are extending and implementing the iterator, then the class can become something that you put in a for each loop. So these are the iterators that are available in the SPL. So as you can see, there are many of them. Some of them are pretty dark. Recursive callback filter iterator, yeah, maybe. But some other are super useful, like directory iterator, file system iterator, and things like that, that allows you, for example, to go through a file system and loop through maybe all the files of the directory or things like that. So let me show you now the example that we had here with what I just show you. So to use these iterators, you have the choice either to implement the iterator interface, or you can implement the iterator aggregate interface. If you implement iterator, you have to implement all the methods like key, next, current, etc. Iterator aggregate allows you to just define which iterator you want, which existing iterator you want to use to traverse the collection. So this is the one we are going to use here, aggregate. And then we have one method that we must implement. So let's delete that, which is get iterator. And then we return a traversable here. So here, because we want to keep it simple, we are going to use the SPL array iterator. So this is how you do it. New array iterator, and then you give it all your items, like this. And here, for each collection, and then it displays all the items. Okay, so that's pretty cool, but you can go way further. You can use many iterators, and then I'm going to show this to you. So we are going to, I'm going to just show you, because we define the direction, so we have backward and forward. And then here, we can do a match on the direction. We can say that if it's backward, then new array iterator reverse these items. And here, backward. Let's remove this. Okay. Forward, yes, of course. Thanks. So here we have backward, and then here we have forward. So you can see that the traversal logic is pretty decoupled from the collection. Once again, it's defined here, but the real logic is inside the iterator. So I'm going to show you another example to show you more of those iterators, because we just saw that there is array iterator. But let's enable Copilot. And then we are going to have a day collection like this, and we have inside private array of days, which contains days like this. Going through them all. That's it. Okay, just wanted Copilot for this. So now we are going to define a constructor with a day count like this, and we want this collection to display the number of days we are going to pass it. So if we have 14 days, we want to show the week twice, and if we pass it 3 days, then we only want Monday, Tuesday, Wednesday. So this is, we are going to do this thanks again to the iterator aggregate, like this. And all we have to do now is to define get iterator. So I said that we want to display days of the week infinitely until we have our count. So infinitely, we are going to use infinite iterator like this. And infinite iterator takes another iterator, so we are going to define our array iterator now with days. So if I execute this code, you can easily understand that my PC will crash. So I'm not doing this right now, but let's write the last part of the code. So we want to display, for example, 10 days, and then for each collection as day, and then echo day. Okay. So I don't want my PC to crash, so I need to limit the number of days I'm showing right now. So for this, we are going to use the limit iterator, which is kind of weird at first because we have infinite iterator, then limited iterator, but yeah, that's it. So limited iterator takes two things. It takes one iterator, maybe an offset if you want, and then a limit. So we are going to give it a limit. Like this, limit, and days count, like this. And why? Because there is, yeah, okay. And now, let's see if my PC crash. No, we're good. We have 10 days here displayed. And if I put 3, also it works. And if I have maybe 15, then I finished Monday with 2 weeks displayed just above. So this is how you can use the SPL iterators that I show you. So these ones, this is the exhaustive list. So you definitely should go to the PHP documentation to see how to use them, even the darkest one, because they may save your life one day. So now let's talk about infinite RAM, as I stated in the title of this talk. Who did this? I'm sure that there is more. Yeah, okay. Who knows this? Oh, wow. Well, this is the end of my talk, so. Everyone using yield, yeah. Okay, so generators are the answer, and it's all about compromises. So, yeah, we all use PHP memory limits at -1, but in production, this is not truly the answer. Because what if you have to go through a data source, and this data source is 1 billion elements in a remote cache? If it is a file of 1 terabyte, if it is a streamed video, or an HTTP response of 800 megabytes, good luck with your RAM, because it can't handle this. And generators are the answer, because generators allows you to create values on the fly. And this is a big promise. So let's see how. Again. So let's take this file out. So for this presentation, I have this little text file that contains a few lines of CSV. But you can easily imagine that it is 1 terabyte long. It will be the same result at the end. So let's declare our generator. So fetch item from terabyte collection. And then we are returning the generator. The generator class is a special class because you can't instantiate a generator yourself with a new keyword. It's impossible. You must pass by a function that is calling the yield keyword, as we are going to see. So let's open our file, which is called data.csv, read mode. Maybe we want to return the number of lines that have been read. And while it's not the end of the file, we are going to yield the data from the file, and then increment the line count, maybe, and then at the end, we want to return the line count, like this. So we are going to fetch our generator like this. So here we just got the generator, but it is not yet executed. Actually, we are just fetching the reference to the generator, but here for now nothing is executed because it is tagged as a generator. And only when we are going to put the generator in a for each loop, then the function is going to be executed like this. And then we want to dump our item. And we can even get the return value of our generator by calling getReturn like this. So what happens here? So if we have all the data from the CSV file. The main difference between what you would do with maybe a for each loop and a collection is that, okay, we are getting the generator here, and then we are calling the for each. And when it's called in the for each, then the generator is executed. So it opens the file, line count, the while, and then as soon as it finds a yield statement, then the value is immediately returned, and the function stops here. So you immediately have the data, and nothing here is executed now. You can do what you want with the data, so put it in another storage or a cache system or things like that. And as soon as you are getting to the next iteration, then the function is resumed. So it will take from here, plus line count, and then while, etc., 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 until the file is finished, and then you return the line count. And this is the main advantage of generator. As soon as you have a value to return, you can return it. So this is why even if the file was 1 terabyte, it's not a problem, because you return the value, you do what you want, and then you go to the next value, and the garbage collector can do its stuff and free some memory. Actually, generators are iterators, as you can see. It implements the iterator interface, so you can have a key, next, rewind, and then you have some other functions like send, throw, but they are iterators. So I said that the generator is executed as soon as you put it in a for each. That's not exactly true. As soon as you try to get the next value, then it will be executed. Let's see now a bit of delegated generation. So, what is delegated generation? You have the possibility, just a moment. Yeah, you have the possibility to yield from another generator inside the generator. So, for example, you have this function which is really concrete, like really, it's real. You are gathering the data from a file, a real file. But you want to do some abstraction, because maybe you want to have multiple adapters that are going to fetch some data from another data source. So let's say real file fetcher, like this. Oh my God. Let's put this in the real file fetcher like this. So static, just because it's simpler. And then we have some, I don't know, it's not abstract, but you get it. Abstract data loader, like this. And this method is doing one thing. It loads. And it returns a generator, like this. And so we are going to, and I want to load data from this one, from the real file fetcher. But I want it to hide from the developer that is going to use the abstract data loader. So what I can do is use the yield from statement, and then do this, like this. And then abstract data loader. And here you go. You just did some delegated generation. So this is pretty neat when you want to do some abstraction, because maybe if I want to have, I don't know, Redis data fetcher, then I just have to change this in the implementation of the abstract data loader. But here, nothing changed, and we have a good responsibility splitting, and then it's more clean. All right, so this is delegated generation. Just going to click this. And now, let's see, you can do even delegated generation plus iterator aggregate. So you have your abstract data loader that implements iterator aggregate. And you can even do get iterator like this. And you know what I'm going to do. Yield from real file fetcher like this. And we can, well, we have to do an instance this time, like this. And there you go. You can directly put your loader in your for each loop, and then it works also. So this is delegated generation. Generators are really flexible. You can, as you can see, you can create any type of generator. So the first thing that you need to do is identify your bottlenecks. If it's the memory, the CPU, maybe the network, you get to find, depending on the problematic you are working on. So yeah, as I said, maybe it's a file on disk, so it's huge, so you have to create some generator that is gathering data from the file system or the memory, or maybe it's on the FTP server or HTTPS server, or anyway. And then you have to create the good generator. And this is how you are going to optimize your performances. This is by really understanding what is the bottleneck in your application, and then creating the good generator that needs to be in your application. What about performances? So benchmarking the range function. Does anyone don't know the range function? Okay, so everyone knows. Okay, great. So Nikita Popov, which is a huge contributor of PHP source code, which is also the creator of the generators in PHP, available since PHP 5.5, did a benchmark to know what are the performances of the generators. So Nikita did 3 implementations. So a native implementation, which is the native range call, iterator implementation, and then the generator implementation. So you have a link if you want to see the benchmarking code. But the results are that generators are up to 40% faster than the native implementation. So that's pretty great. But also generators are up to 400% faster than the iterator implementation. So as you can see, even for your CPU, it's a good thing, not only for your I/O, your memory, your network, etc. Even for your CPU, it's always a good thing to use generators. So I quoted Nikita that says that for small ranges, around 100 element, generators are slightly slower than the native implementation, but still faster than the iterator variant. So how do they work? If we have a look at the reflection API of PHP to have a look to the reflection generator, we can see a few interesting things, like we have the executing line, executing file, get function, get this, etc. And in fact, generators are storing the code snippet, actually, that is creating the values on the fly. So we have the proof that really it keeps a trace from where it is in the source code, and it doesn't store some values somewhere, etc. So yeah, this really works. And if we dive into PHP internals, so promise it will be not that hard, we can see that generators are stored in a structure that is called Zen generators, and this structure stores the instructions of the generating function, the execution context, some local variables, and the current instruction. So we can see that no generated value is stored, and garbage collector can do its job, as I told you earlier. So this is the Zen generator structure. So if you want to have a look, you can head up to the zengenerators.h file of the PHP source code, which is where generators are defined in the PHP engine. In third-party libraries, they are everywhere. So an example with Symfony, in the console components, it manages the output of your command to have some real-time output, plus preserves memory and don't keep the entire output in memory. In the Finder component, you can discover these directories and file lazily, because when you want to go through a file system, you don't want to load the entire file system to see all the directories and files. In HTTP Foundation, you can stream responses with big files, for example, so you preserve network, memory, and I/O. HTTP client allows to do some responses multiplexing, and the process component uses generator to fetch running processes output, like the console component, to have real-time output and preserves memory. In Doctrine, also, you can fetch an entire table by calling the toIterable function method when you are using a query builder, and then Doctrine internally will use a generator to gather elements one by one instead of getting everything at once. So sometimes you have problems with Doctrine because it takes too much memory, because you have too much entities in memory. Well, you can use toIterable to get your entities one by one. Again, it's all about compromises, because when you are doing this, you are multiplying the number of requests to your database. So it's not always a good solution, but it can save you. In PHP unit, you can define some data. You can define your data provider with generators also. It is pretty useful when you have huge data providers. In our team, we choose to declare all our data providers as generators. Well, this is a good practice that we have in intern, but this is not something that you must do every time. But if you have huge data providers, maybe this is something you may consider. It is used in LazyStream, so this is a library that I created that allows to open a stream. So it may be Google storage bucket, it may be an FTP file or anything, and it takes a generator and takes the values from the generator to this destination. The main advantage is that, as you can see, we have our generator that creates some JSON data. We are creating a LazyStream writer, but nothing happens here. It will wait for you to call the trigger method to do anything. And then, when you call the trigger method, then the generator is unwrapped, the connection is initiated, and then all your data are sent to the destination. This is what we use for our project with all the models, chairs, 3D models, etc. We have a big generator that is generating big JSON files. And then, because they are pretty big, we don't want to have everything in memory, then send them to our Google bucket. So we have a generator that creates the data and send iteratively to our bucket. Tomorrow in yours, I highly encourage you to use generators because, as you can see, in performance for your CPU, I/O, memory, etc., everything, it will be better. And yeah, this is truly a beautiful feature of the language, so you should definitely use it. Thank you very much.
You want to do Q&A?
Yeah, why not?
Okay.
Yeah. You have any questions?
Any questions?
You're using you're using example just now from using getting an iterator from Doctrine.
Yeah.
Wouldn't that end up loading all the entities in memory anyway? Because it's not like it clears all the memories it has, right?
Yeah. So this was a pretty basic example, of course. But if you want to truly have something optimized, you can use a toIterable, and also you have to clear the unit of work regularly.
But that would work with the iterator then. It would know then if you clear, like after 100 you clear them, it would know that you stuck until.
Actually, the only thing that changed is that instead of having one big request that gathering whole, it will do one request by entity. So.
Yeah. Okay. Yeah. Then would still know.
So you can clear the unit of work and then.
Yeah. Because it haven't fetched it yet, so it doesn't know that it's. You can't clear it because it hasn't been fetched yet.
Yeah.
Yeah. Okay.
Anything else? No? Well, perfect. Thank you very much.